a ball of mass 100 gram and having a charge of 4.9 into 10 to the power minus 5 coulomb is released from rest in a region where a horizontal electric field of 2 into 10 to the power 4 Newton per coulomb exists. The question is asking find the resultant force acting on the ball, what will be the path of the ball, and where will the ball be at the end of 2 seconds. So this is the question that is asked. So I am considering this way that this is a ball. Now it is placed in a region of horizontal electric field. So I am considering that the electric field is in this direction, and the value of electric field is given to us as 2 into 10 to the power 4 Newton per coulomb. Now the force which is acting on the ball can be written as QE in this direction and a force mg in this direction due to the gravitational force. So the first thing that we do is we calculate these two forces individually. So first of all we are calculating the gravitational force which is acting in the downward direction, which is equals 100 gram. We are dividing it by 1000 to make it into kg and then multiply it by 9.8 meter per second square. For this particular question we are using this value of g as 9.8. So on getting this we get 0.98 Newton. Now the next thing which we calculate over here is the value of or the magnitude of electrostatic force, which is equal to QE. So if I put the value, the charge is given as 4.9 into 10 to the power minus 5 multiply by 2 into 10 to the power 4. So QE is again going to give us 0.98 Newton. So for this particular question, we say 0.98 Newton is the force for both the gravitational part and this part. So we are going to say that the net force which the particle is going to experience is going to be the resultant of these two forces. So the resultant force is going to be F electrostatic square plus F gravitation square. Now since they both are same, so we are writing it as root 2F. So if I multiply it by root 2, so we are getting somewhat like 1.38 Newton. So for this particular question, the first answer is 1.38 Newton. Now the question is asking what will be the path of the ball. Now since the resultant of both these forces are in this direction and they both are equal force, so I say it is making an angle of 45 degree. So I can easily say that the particle is going to move in a straight line along the resultant force at an angle of 45 degree with the horizontal. So this is going to be the path of the ball. So the next one which is asked is where will be the ball be at the end of 2 seconds. So now at the end of 2 seconds, now since the horizontal and the vertical forces are same, so we first of all calculate the displacement along the vertical direction, which is going to be equal to the displacement in the horizontal direction. So the magnitude of both of them is going to be same. So ut is 0, we just need to do half at square. A is 9.8 and t square is 4. So over here we obtain 19.6 meter. So the net magnitude of displacement is going to be vertical square plus horizontal squared square root. So on solving we obtain 19.6, again the same thing. So we write it as root 2 times of 19.6 and we get a equivalent value of 27.7 meter. So for this particular question, these three are the answers which we obtained.